Welcome to Private Cloud for the Home User. My name is Max Holmes, and I'm a Technical Account Manager for Synology. My team specializes in providing product education, support, and recommendations to businesses and home users just like yourself. Today is a very special presentation that we created specifically for our home users. Synology creates a lot of products for businesses, but we still love and highly value our home users. We're always excited to teach people about Synology products, but this time we're going to use a little bit less of our regular technical mumbo-jumbo. However, even if you're pretty technically savvy, you'll probably still learn a thing or two about Synology. We're going to be learning about what a NAS is, what it does, how it works, and then we're going to give you the tools to choose your own NAS that fits your data requirements and goals. Finally, we're going to dive deep and walk through a start-to-finish setup of a Synology NAS. So let's start basic. What is NAS? Well, NAS is an abbreviation for Network Attached Storage. The network attached portion means the device is connected to your home or work network. Devices that are on a network have the potential to see and communicate with each other. Devices you might already have in your home that are network attached are computers, your phone, or even your TVs. Now, if you've ever casted the screen from one of your devices to your home TV, that's only possible because both devices are attached to your home network, so they can communicate over it. The last letter in the abbreviation seems pretty straightforward: storage. Well, a NAS is a storage device. It's a hub for all your personal files, making them pretty easy to access by devices on your network. Now consider this example for yourself. Have you ever tried getting a photo from one computer to another? You probably ended up emailing it to yourself or uploading it to the cloud and then downloading it again on the second computer. Now if the file was on your NAS, the transfer would happen with a couple drag and drops. So where does the data go on a NAS? Well, just like a computer, it goes on a hard drive, and in most cases, multiple hard drives. Now these drives are loaded into the front of the NAS. The NAS unit itself comes in varying sizes and capacities, from a couple bays to devices that can take a ton of hard drives. Let me show you a couple. In front of me, I have two Synology NASs of different sizes. On my right-hand side, I have our DS720 Plus model. This is a 2-bay NAS. Now on my left-hand side, our DS1819 Plus model, and this is an 8-bay NAS. Now to install a hard drive in a NAS is pretty straightforward. All I have to do is remove one of the drive trays and install a hard drive into the tray using the included hardware. After the hard drive is installed in the tray, I just reverse the order, slide the drive right back into the NAS. Now Synology makes NASs of a lot of different sizes and shapes, and even some really big stuff. In fact, if you're a video production company and have an extra $30,000 lying around, you might want to consider one of our full flash arrays, which is loaded with SSDs and meant for a production environment. A NAS isn't just a big hard drive on a network. Storage is just the beginning. A NAS can actually do a ton more. You should kind of think of a NAS like a mini computer. It actually runs its own operating system. Now at home, your PC probably runs a variant of the Windows operating system, or if you're a Mac user, then you're probably running Mac OS. Now Synology's operating system is called DiskStation Manager, which we usually abbreviate as DSM because it's kind of long. It comes license-free with all our NAS units, and it's what gives a NAS its vast amount of functionality that a regular external drive just doesn't have. Now within DiskStation Manager, we download software through what we call our package center. It's like our own built-in app store, but the softwares in it are free, so it's kind of not like the app store in that way. Now by installing software to the NAS, we're customizing its functionality to suit our own needs. We'd be here all day if I started listing off what a Synology NAS can do. Common functionalities of a NAS start with basic data storage, sharing, and security, but they go way further than that into things like media servers, surveillance systems, website hosting, and in fact, more than you could even imagine, all from a single NAS. But most importantly, and above all, a NAS keeps your data safe. We'll come back to data security in a minute. There's a lot of ways to store your data in this day and age. From your phone, your computer, there's a bunch of cloud services. Maybe you throw all your files on a USB drive every month. Well, why is a NAS the best option? Well, there's some serious advantages to having an on-premise storage. It's lightning fast, reliable, secure, and it's the most affordable. If you're like me, you've probably accumulated a lot of data over your life, and losing that data would be absolutely catastrophic. And we often don't think about it until it's too late. data reliability is so important because your data is irreplaceable. Now, Synology makes your data extremely reliable by creating redundant systems within the NAS that prevent data loss in the event of a hard drive failure. Now, we also need to back up our data to prepare for the event of a total failure or some sort of malicious attack. Now, creating that redundancy lies in the ability to have a fail-safe on the system. Hard drives that are in a NAS are configured so that we can lose certain drives without losing all of our data. Now, this configuration is called RAID. We're going to learn a little bit more about RAID later. For now, let's use your home computer as an example. If you lost your computer's hard drive, you'd lose all the data. If that data was on a NAS, losing a hard drive wouldn't cause a total data loss. Since our hard drives are in a RAID configuration, we can lose a hard drive or two without losing all our data. Now, the other half of our reliability strategy is backups. A backup is a copy of your data, which is stored in a different location or on a different device. This creates layers of recovery options in case one of the backup devices is somehow rendered useless. Now, if we had a second NAS off-site, our data would be safe in the event of a natural disaster or maybe a virus that rendered the NAS useless. One of the largest advantages to a NAS is its ability to rapidly read and write data. The secret to a NAS data speed lies in a topic we've already mentioned, the network attached element of our NAS abbreviation. Now, your NAS is plugged into your home network. We call this network your LAN, or your local area network. LAN is a connection between all the network devices in your home. When two devices communicate over our home network, they're communicating directly with each other through the wiring or the Wi-Fi in our home. This direct connection is extremely fast. Now, when we send data into the cloud, we send it out of our LAN and over the internet. This causes a serious speed reduction as the data has to bounce between a bunch of various servers and cables throughout the entire world. Now, even if your home network is really fast, once the signal is sent out into the internet, it's basically out of our control. It's at the mercy of the connection speed of each server it bounces between. Now, here's a comparison of transfer speeds between our home computer in the cloud and from our home computer to our NAS. We're talking 1,000 megabits per second to our NAS, and on average, only about 70 into the cloud. Now, that's only if your internet provider blesses you with 70 megabits upload speed in the first place. That's double what I get at home. So let's visualize this difference. Yikes, that's not even close. So say I wanted to upload a 4K version of my favorite movie. I want to upload it into the cloud and into my NAS. Assuming I'm in the United States and I have an average internet speed, if I was going to upload my movie to the cloud, I'm looking at over 3 hours of transfer time. Now, to my NAS, 15 minutes. And on top of that, uploading and downloading files to a NAS is super easy. Check this out. All right, so I have DSM open in a browser here, and I have this suspiciously named Upload Me text file. So what I'm going to do is I'm just going to click and drag it into the NAS, drop it, and the upload process starts. The download's just as easy. We just right-click, hit download, and you can see it pop up at the bottom of the browser and eventually pops up on our desktop. It's pretty simple. In addition to physical security, a NAS is a master of cybersecurity too. Now, within the NAS industry, Synology is known for having the best track record for cybersecurity. Our products are even approved and extensively used by the US government, so you know they've got to be safe. Synology does not take data security lightly. It's a top priority for us, and we spend a ton of our time testing our hardware and software for vulnerabilities. But aside from Synology doing their part, owning a NAS gives you the power to prevent unwanted access to your data, block malicious attacks, and generally keep your data under your own control. The DiskStation Manager login system employs the latest in password confirmation standards, as well as end-to-end encryption while data is in transit. And since connections happen over LAN and not through a third-party server, there's no middleman who could potentially spy on your data. We access our NAS using a username and password credential, and once logged in, users can perform various tasks and access data. We can control what each user does within the NAS by setting up user permissions. Now at home, we might set up our user profiles kind of like this. We have an unlimited access admin account that can do anything on the NAS, including install software, change network settings, delete users, admin stuff. Now our parent user might be able to view all the files and data on the NAS, but maybe not install software or modify settings. Finally, our children user is the most locked down and the children can only look at what's in the Children's Movies folder. Now, setting up user permissions goes hand in hand with our next topic, which is malicious attack protection. Let's say our computer gets hit with a ransomware attack and it starts encrypting all of our data. Now, since the computer is connected with the parent user's login details, the virus only got access to what the parent user could access. Now, in this case, the Documents, Photos, and Videos folder were infected. However, since the parent user didn't have access to the Backups folder, the infection was unable to spread to the backups. From there, recovering our data is as simple as logging in as our admin user and restoring our files from our non-infected backup folder. All right, some of you might be thinking, the cloud can't be hacked, so my data is obviously safe there. Well, the cloud is usually a good way to prevent attackers. However, a 2020 survey by Security Magazine showed that over 80% of companies have experienced a cloud data breach in the past 18 months. Now, as an individual and not a business, it's true, you might be less of a prime target, but there's a little bit more to the issue. What we aren't considering is data ownership. Once your data is in the cloud, you can never be certain who's accessing it. If the data is hosted on a third-party cloud service, they might have the rights to read your data or even provide it to their affiliates. In this case, you become the product. Let's say I just went on a hike with my friends, and afterwards, one of us uploaded our pictures from our hike to a cloud service. Now, right away, that service starts scanning the photos and mining them for data. They find out the brands of clothing we were wearing, our age group, our location. They can even draw conclusions about race, gender, income, and relationship orientation. Now, this is the start of an advertising profile built on me and my friends. Now, I know this sounds like a plot to a sci-fi movie, but this is actually reality. Now, keep in mind that regardless of your own choice, if your photos are going into the cloud, you could be making the choice for your family and loved ones without them even realizing it. So how easily and quickly could you get your data back if you needed to? Well, cloud providers have control over the cost of your data, even though you own the data. They can change their subscription pricing at any time and force you to pay more to get access to your data. Imagine the time it would take to get all your data off the cloud, since all the download and upload happens over this slow internet. I hope your internet's fast. All right, I don't want to make the cloud seem worse than it is. While there are a lot of advantages to having an on-prem storage like a NAS, the cloud does have its perks. It's actually a great way to store backup data and not have to worry about managing any hardware, because they're going to manage it for you. And since you only use your backups in a data emergency, the difference in speed to the cloud for a backup doesn't really matter as much. For this exact reason, Synology's Hyper Backup software was designed with the ability to send data right into the cloud. But if you want the easiest way to send your data into the cloud, you should consider Synology's C2 service. Now, it fully integrates into DSM, and with a few clicks, you can start backing up right to the cloud. So later on when we're setting up our NAS, I'm going to show you how to send some backups into the C2 cloud. And last but not least, there's cost. Now, if you're not currently storing all your own data, you're probably stuck paying for a subscription or some sort of licensing. Let's talk about some of the prices of Synology's software and features. Well, okay, there isn't actually much to talk about, since Synology's software is license-free. That means you get various software packages, updates, technical support, all license-free. You purchase the hardware, and that's it. Data storage isn't a short-term need. You'll likely spend the rest of your life storing your data somewhere. At first, it might not seem like a lot, but subscription plans add up quickly. In the long run, that cloud service that seems cheap is going to start costing you because you're continuing to pay indefinitely. Now, you're probably thinking, this seems too good to be true. I need a NAS. So how do I choose the right NAS for my home? NAS units come in a lot of different hardware configurations. So when we're choosing a NAS for ourselves, we need to think about some of our personal requirements. There's a lot of specifications to consider, and sometimes this can get a little advanced. Let's break it down to the major specifications to consider when we're choosing a NAS. To pick the right NAS, we're going to consider how much data we have, how demanding of tasks we need our NAS to perform, and how fast our data is growing. So take a second to think about it. How much data do you have? Now, if you're not sure, we can figure out some rough numbers with a little investigating. Let me show you some quick tips on how to get an idea of how much data you have on your computer. Okay, so in Windows, I'm going to right-click my Family Photos folder, and I'm going to go down to the properties at the bottom of the menu. Now we'll see that there's a size parameter. This will show us that the folder is 195 gigabytes in size. We can do a similar thing with our hard drives on our computer. So in the This PC section of Windows, we'll go to our hard drive. In this case, it's named Local Disk C. Right-click, Properties, and we'll see under Used Space, this hard drive has 243 gigabytes of used space, and that's how much space we'll need to back this up. Even if you're confident in your current data needs, I always recommend my clients think 5 years into the future. Now, if you're a home user, your data could easily double. Small businesses can see tripling data, and larger, fast-growing companies sometimes see unexpected exponential growth. You wouldn't want your NAS to fill up and then have to buy another one. Now, since we're already talking about data, this is a good time to learn about RAID. Now, I mentioned RAID a little bit earlier when I was talking about hardware redundancy. Remember, redundancy is the idea that there's always a failsafe on the system, and in the case of a NAS, that's done using what is called RAID, or Random Array of Independent Disks. RAID is a technology built into your NAS that allows you to configure groups of hard drives to work together. Half the advantage of RAID is increased performance. We can split a larger file up into smaller pieces and distribute it between multiple drives. This effectively makes the drives work together and increases speed significantly. The redundancy portion of the RAID advantage depends on which configuration we choose. RAID 1 is what we call a mirrored configuration. We have two sets of hard drives that are identical, and any data that goes on one group also goes on the other. So if we lose one group, we always have the mirror to fall back on. This could be 2 drives, 2 sets of 2, or 2 sets of 4. Our next example, RAID 5. This is actually the most common RAID setup for a NAS, and it's the one I recommend to my clients most. RAID 5 requires at least 3 hard drives and allows for any single drive to fail without losing all the data. This RAID also increases performance because we have the data split between multiple drives. Nearly identical to RAID 5 is RAID 6, which provides an additional drive redundancy on top of RAID 5. So we have 2 drives that can fail without data loss. Now for this, we need a minimum of 4 drives total. Finally, we have Synology's hybrid RAID technology, which allows us to RAID hard drives of different sizes. Now this isn't possible with traditional RAID types. And like RAID 5, we can also lose a single hard drive without a total data loss. But SHR should only be used when budget is the top priority, as the performance of a traditional RAID is generally better. We also have SHR2 if you want that RAID 6 redundancy of 2 drives. Now in a quick comparison table, you can see that all the RAID types are similar, but each strategy has its own pros and cons. So we understand how much data we have and how many hard drives we need to set up a RAID. Now we need to understand how powerful our NAS needs to be to perform our desired tasks. Now the power of your NAS, which affects the responsiveness and workload capabilities, is largely contributed to 2 pieces of hardware. Your CPU, which can be thought of as like the brain of your NAS, and the RAM, which is kind of like its short-term memory. Now a faster CPU contributes to increased responsiveness of user inputs and tasks. It also allows the NAS to perform more intense tasks more quickly, such as handling a lot of cameras or maybe hosting a website. More RAM increases the number of tasks that can be run at the same time without decreased performance. It also helps the NAS handle larger data. Okay, so you've bought a computer before. You've probably seen these numbers. CPU speed is expressed in gigahertz. The higher the number, the faster the processor. But there's also core count. The more cores a CPU has, the more it can break a task up between cores and finish it faster. Now, unlike CPU, RAM numbers are not a performance metric. They're a storage capacity, and RAM is rated in the gigabytes. Now, generally, more RAM is better. However, you won't see any performance gain if the system itself doesn't demand more RAM. It's kind of like if your office desk was twice as big, you might be more productive. But if it was 10 times as big, it probably wouldn't help at all. RAM is the same way. Now here's a NAS I configured with my mom in mind. She's been taking family photos since I was a little kid, and she needs somewhere to store them safely. So I chose a 2-bay NAS, and since it's a 2-bay NAS, we're going to be setting it up with RAID 1. She needs 4 terabytes of total storage, so we need 2 4-terabyte drives since RAID 1 clones the data onto a second drive. Now this NAS comes with a 1.4 gigahertz dual-core processor and 4 gigabytes of RAM, which is plenty for a NAS that's just going to be used as a secure storage. Now, let's go polar opposite and spec something really powerful for a large business. So for this business, we're looking for over 500 terabytes of storage. We're going to need to get a NAS configuration that will take 36 16 terabyte hard drives in order to meet this goal. The CPU is a 12-core, 2.7 gigahertz CPU, so it's going to be running some intense business software. Finally, we need a whopping 128 gigabytes of RAM, since this NAS is going to be hosting virtual computers, and a lot of them. If you still need help choosing a NAS, there's a nifty tool on Synology's website. We can go down to the bottom of the page and select NAS Selector in the bottom left-hand corner. For this demo, I want to pretend like I'm a big business. So let's select Business or Enterprise. Next, I'm going to say we're going to be using the NAS for data backup. And then I'm going to say we have 20 to 100 users. But our concurrent users are under 100. And then throughput, which is how much data we need to move on the NAS at once, let's put that at the maximum, 1,000 megabits per second or over. Now, because of these parameters, it's going to recommend us NASs from the XS and XS Plus series, which are more like medium to large business. You can see there's a DS model and an RS model. So let's refine this. I'm going to go up to Select More Features, and I'm going to select we want a rack mount unit. And let's say we want it to have upgradable RAM too. So now that we go down, we see the DS model is eliminated. Now another cool tool is our RAID configurator, RAID calculator tool. So we get to choose hard drives and see how they interact with different RAID types and what available space they yield. Then, based on the RAID we set up, it'll recommend different NAS models. Here's the DS920 Plus. This is actually the NAS I have at my home. Before we jump into setting up our NAS, let's quickly outline the topics that we're about to see. First, we're going to unbox our NAS. We're going to install some hard drives. We'll attach the provided cables in order to get it on the network. Then we're going to jump into a computer where we'll discover the NAS on the network. We'll go through installing our operating system DiskStation Manager. And after that, we're going to finally be able to log into our NAS for the first time. We'll then create our storage pool and volumes where we set up RAID. We'll add some user accounts, install some software, and finally, upload some data. All right, so let's get our NAS set up. Here I have a DS1520 Plus NAS. It's a 5-bay NAS with a 4-core processor and 8 gigabytes of RAM. Inside, we have an accessories box which contains things like the NAS's power adapter, hard drive installation hardware, and a network cable. In addition to the hardware, we also have the NAS unit itself. The only thing we're missing is hard drives. Now, Synology NASs support the traditional spinning disk hard drive as well as a solid-state drive. Now, your home network probably has a gigabit connection and won't take advantage of an SSD, so we recommend a traditional spinning disk hard drive. Now in this NAS, I'm going to be configuring RAID 5 with 3 drives. Remember, RAID 5 means we can lose one hard drive without losing all of our data. So let's get these installed into our NAS. Installing a hard drive into a tray is pretty straightforward. All we have to do is set the hard drive in the tray and make sure it seats all the way to the bottom. That way the holes on the sides will line up. Then we fasten the hard drive in place using the included brackets. There's one on each side. Once they click into place, the hard drive is ready to be reinstalled into the NAS. Slide it all the way in, click to close. Now that our hard drives are installed, we're ready to power up our NAS. Last but not least, we're going to install our AC power adapter, and then from a router or network switch into the NAS, our Ethernet cable. That's all there is to it. All right, here I am on my home computer. And if you didn't already know, we connect to our NAS through a web browser. Now what I'm going to do is discover the NAS on the network by going to find.synology.com. So once we're on that website, it's going to automatically start searching our network for attached Synology devices. Now once it's done, you'll see it'll pop up the information about the NAS. So here's our DS1520 Plus. Now under status, it says not installed because we haven't installed the operating system. So let's go ahead and hit connect and we'll install the operating system now. And throughout this process, you're going to be pretty familiar with a lot of these procedures because they fall in line with general software installation. We'll see some downtime, some loading, stuff like that. A lot of terms and service. Okay, so now here's our welcome screen. We'll hit install and it'll start the installation process. So it's going to warn us that our data on our hard drives are going to be wiped because we're installing for the first time, but that's okay because these are brand new hard drives. Now this download, setup, restart process is fast forwarded, but usually it takes about 15 minutes. All right, so the first setup procedure we need to do is give our device a name that the device will be shown as on the network. So I'm going to say home user NAS here just so we know what it is. Then under admin account, we don't want to use admin because that's not secure and very easy to guess. I'm just going to use my first name. It's a little more difficult. Then I'm going to use a good password that I can remember and continue on through the setup. Now this is our admin account, remember. I'm going to have it automatically install updates for me and not change this setting. And finally, if we already have Synology products, I can sign in with my existing Synology account here. But for demonstration purposes, I'm going to create one now to show you how easy it is. Basic account creation information, you've seen this before. Subscribe to our newsletter. And then the last part of this is it's going to send us a verification code via email, which we need to enter here. Pretty simple. I'm sure you've done this before. Okay, so now that we've signed into our Synology account, or created one, it'll link the account to the DSM. So if we ever have to interact with our account from within DSM, we can do that. Here, it's going to ask for a Quick Connect ID. This is the ID we use to connect to our NAS remotely. But I'm going to skip this for now. We're going to set this up later. Okay, so now we're in DSM 7. The first prompt we're going to get is to create a storage pool and volume because there's nowhere to put data right now. And we don't have a RAID set up. We just have a bunch of hard drives in the NAS. So I'm going to hit Create Now. It's going to jump us into the storage creation wizard. So we see this little infograph kind of explaining storage pool versus volume. A storage pool is a group of hard drives, and it's the layer we set our RAID up on. And a volume is like a bucket for our data within the storage pool. We can have multiple volumes for different purposes, but usually one volume is plenty. Now here, it's going to ask us what type of RAID we want to set up our storage pool in. Like we said earlier, we're going to use RAID 5, which is a single hard drive redundancy. So I'll hit RAID 5 here. And then we can give an optional description just to help us differentiate between our storage pools and volumes. So I'll say main storage pool. We'll select the drives we want to put in the storage pool. Generally, you're just going to select them all. Here's the usable capacity after the RAID. And finally, it's going to say how much of that usable capacity do we want to give to our volume. And in this case, I'm just going to hit the max button because I want to give everything to the volume and use all our space. Great. Volume description, also optional. I'm going to say main storage volume instead of pool. I'm going to leave the file system as BTRFS. This is our recommended. It has great features. It's a great file system. Overview of our settings. Finally, now that we're creating RAID, it's going to warn us one more time. These hard drives are going to get wiped. Totally fine. These are brand new drives. Okay, so now we're going to see our storage pool and volume pop up in our storage manager. If we expand these, we'll see some details like the hard drives that are part of it, the RAID type, and we're also going to see this optimizing in background. The parity that creates the redundancy in the RAID actually takes time to build. So we'll have to wait a little bit for this, and the NAS will run a little bit slower, but that's okay. It's only temporary. All right, so let's go to File Station. This is how we interact with files and folders on the NAS, like our data. So I'm going to open this guy up. I'm just going to say, there's no shared folders. What are you trying to look at? Well, that's true. What we need to do is set up a shared folder to put data into. This is how we categorize. So I'm going to say, okay, let's do that. And it'll take us back into Control Panel, into the shared folder creation wizard. Now, we need to create quite a few shared folders for different types of data. So what I'm going to do is back out of this and show you how we got here in the first place, so we can do it again later. So let's X these out. I'm just going to go to Control Panel here on the desktop, and then the shared folder category. Cool, that was easy. So now we'll hit Create, and we can create a shared folder. Now before I continue, I want to let you know this is a good time to think about how you're going to organize your data. Now at home, I have shared folders for different purposes, like photos, videos, documents, that kind of thing. But you get to decide your own fate here. So I'm going to click Create Shared Folder, and the first folder I'm going to create is the Documents folder. So let's just put Documents in here. And just like the volume and storage pool, we have an optional description field. I'm going to say personal documents and files. We don't have to do this. I'm going to leave the rest of the settings default. Once again, encryption, no encryption. Let's leave that default. A lot of the time, these default settings are the best for a home user. Advanced settings, default. Here's our overview of what we're about to create with the name and what volume it's on. Pretty simple. Now we can give user access or deny access here at the end of the wizard, but we can also go back into our user settings and set this up later. So for now, I guess I'll give no access to admin and guest since those users aren't going to be used. So I'll hit apply and our documents share is created. So in fact, at this stage, we're ready to go into FileStation and actually upload and download data into the documents share. It's usable. But you know, before I do that, there is going to be one more person using my NAS, and that's going to be my girlfriend. So let's create a user for her. I'm going to go Control Panel, User and Groups, and then we'll see a list of the users that are here already. So by default, there's an admin and guest user, and they are disabled because they're common names, and the more common a name, the less secure. So our max user down there is actually our admin in this case. So I'm going to click Create and do Create User. This is where I'm going to enter Alana's name because that's going to be her username. So I'll say Alana here. And next, this is pretty important. When Alana logs in, she's going to want to change her password. So what I'm going to do is generate a random password that she'll log in for the first time temporarily, and then she'll change it to something she can remember. Now we can assign her to a group here, which is a set of permissions like admin. Actually, no, I don't want to give her admin. Let's take that off. We don't need her to change settings on the NAS. Okay, so here's the documents folder we can give permissions to. I mean, I think she should be able to use documents, so let's give her read-write on this. And finally, this is a quota, how much data she can upload and download. We don't want to limit any of this kind of quota type stuff. Application permissions, whether or not you deny access to a single software or not another one. This is a upload-download speed limit if we only want them to upload or download a certain speed. Also unlimited. There's only 2 users, so it's not going to create a big issue. All right, so the Alana user is created. You can see it there under admin. And in fact, at this stage, it's ready to be logged into. She can log in for the first time and start interacting. So what I'm going to do now is I'm going to create a second share. But this share, I'm going to name development. And this is only going to be for my personal coding files. I'm not going to give Alana any access to this because I don't want her to mess around with my coding. So what I'm going to do is hit no access next to the permissions on Alana, and that will mean her account will be restricted from accessing the development folder. So to demonstrate this, what we should do is log out of our max user, and we'll log back in as Alana. So once we log in as Alana, we can see the difference. So we'll just put her username in here. We'll use the temporary password we assigned because she hasn't logged in yet. And once we're in DSM, it's going to say, hey, welcome to DSM. Well, that's only because this is the first time she's logged in. So now in FileStation, we'll see no access to the development folder. We only see documents, which we did give her access to. And this is how we create that security level. We can also see she has no access to a control panel. This is the type of security we need to employ to prevent viruses from accessing our backups. Okay, back to the max user, which is our admin. We need to mess around with our control panel. Okay, so now we have some shared folders, volumes, etc. We need to connect to our NAS remotely. So right now, if you look in our browser, you can see we're connected with our local IP address. Now that's bad because it's hard for humans to remember IP addresses. Numbers are way harder to remember than words. So our Quick Connect in Control Panel and External Access is going to give us a word to connect with instead of a number. So what I'm going to do is enable Quick Connect here. And our Quick Connect ID can be something unique of our choosing. Now, it can't be a duplicate of someone else's, so it might interfere, but let's try to do something unique. So I'm going to say Max Home NAS. There's probably not another Max Home NAS. Okay, now I'll hit Apply. It's going to search the Quick Connect database to see if it's a duplicate. So it wasn't, so it's going to say registering. It's going to put our information in. And finally, we'll get a link to connect to our NAS remotely. Now, we can put this on our bookmarks bar, and we can just click this to log into the NAS anytime. This is how I connect normally. So we'll go home. We can also go quickconnect.to. This is the Quick Connect website. And then enter our Quick Connect ID. We can do this anywhere in the world, a hotel, a friend's house. From our phone, we use Quick Connect with a lot of our apps. Here we are, Quick Connected right back into our NAS. So let's enter the max credentials once again. Bam, we're in the NAS. Okay, so the last thing, let's install some software. We're going to click Package Center, and you'll see it in this All Packages category. There is a ton of packages. I mean, you can get lost in this. But for the demo, I'm just going to use our Hyper Backup package, which is one of our backing up protocols that will push data into the cloud. So I'm just going to hit Install. And it'll go through the regular installing process, like downloading, unpacking, that type of thing. So we'll let it install for a couple seconds, and then once it's done installing, that text is going to turn green. Okay, so now we see it's running. Once a package is installed on a Synology NAS, it automatically starts running. So we could hit open here and start the software, but actually we want to be able to easily access this in the future. So I'm going to go to main menu and drag the Hyper Backup icon to the desktop, and now we have it as a shortcut, and we can access the software this way. So we can close Package Center. We don't need this anymore. All right, so let's open our Hyper Backup. Here it is, and we're going to make a backup task. So I'll click the plus here and do Data Backup Task. It'll show us all the places we can send our data, like a local folder or a USB drive. We can do Dropbox, Google Drive, Synology C2. There's a bunch of stuff. For the demo, we're going to show you how easy it is to send data into the C2 cloud. So let's hit Next. It's going to pop up a browser on the C2 website, and it's going to ask us for our Synology email, which we created at the start of our demo. There we go, we're signed in. Now it's going to say, welcome, and we're going to hit Get Free Trial. There's a 30-day free trial on the C2. We're going to choose a plan that fits our data. Let's say I need 1 terabyte and I want to pay monthly. So let's go ahead and hit Next. Once again, generic software type stuff, user agreements. It's going to ask for a credit card in case we go over that 30-day period. Okay, so here's our plan details, our first payment date. And finally, once we hit OK here, it's going to give us an estimate of our data usage, but in this case, we haven't backed up anything, so you'll see 0 bytes used. Finally, once we hit Allow, it's going to link our C2 account with DSM and allow us to back up automatically into the C2 cloud. So any backups happening here are going into the cloud, and they're secure even if the NAS is broken. Let's name this NAS Backup so we can remember the backup directory name. And finally, we'll see we get to choose volumes and shared folders. So this is the data we are going to send into the cloud. We can choose individual shares or the entire volume. Application settings can be backed up, but I'm going to opt out of this. I just want my files and folders. More advanced settings like schedule of backup, we'll skip this for now. Now it's going to say, do you want to back up now? Well, of course we do. It's a demo. Let's see it back up. So now it's going to initialize our backup. And remember, we only have 1 text file in our document folder, so this is going to be super fast. But the speed of the backup is going to change based on how much data is going. And remember, this is going out into the internet. There's a success. Now we can also access the data in our NAS without actually logging into DSM in a browser. We can do this by mapping a NAS's share as a network drive. This will allow the share and the data within it to show up in the This PC section of your computer. So I'm going to open This PC, and you'll see our local disk C in the bottom left. So what we're going to do is select Map Network Drive in the top left. Now if you don't have this Map Network Drive button, it might be because this taskbar isn't expanded. So let's expand that down and click Map Network Drive. So now we're going to give it a drive letter. I'm just going to use S for Synology. For the folder, we're going to do 2 backslashes, the name of our NAS, another backslash, and the name of the share we want to map. I'm going to map the documents. Then we have to be sure to do connect using different credentials because we have to connect with the NAS's login. I'm just going to use the max login and password. Also, I want to remember the credentials so it automatically reconnects. Now, one disclaimer here, the max user is our admin user for our NAS, and this is generally a bad practice. You should have a separate user that doesn't have admin credentials that connects to the computer. That way, if a virus attacks the computer, it doesn't have admin access to the NAS. We talked about this earlier. So I'm going to go ahead and hit OK, and it'll finish mapping the drive. And we'll see the share, the document share, will show up below the C folder, and it can be used just like a hard drive. Here's Max's document from earlier. In fact, I have another document, Max's new document. Let's drag this into the share and see what happens. All right, looks like the copy happened, but did it happen on the NAS side? Let's go back into DSM and click File Station. Now we'll click our Documents Share. Oh, lo and behold, Max's new document has arrived. Let's delete it. Will it delete it from the PC side? Of course it will, because the PC side is the NAS side. It's just linked. You see the file is missing. This is a great way to interact. All right, so let's recap what we learned. We learned that a NAS is a network-attached storage. Our NAS is filled with hard drives which are configured in RAID to protect the data. We can configure different speeds of CPUs and different capacities of RAM, both which affect our NAS's performance. A NAS can perform various functions. We tailor our NAS's functionality by picking and choosing software from Synology's Package Center. Our NAS is connected to our home network or our LAN, so users and devices can easily access and manage our data. Finally, to secure our data, we can easily back up to another offsite NAS or a cloud service for a fully comprehensive data solution. Still want to learn more? Be sure to check out our YouTube channel, which is jam-packed with informational videos on Synology hardware and software. In general, it's a great resource. You can also check out our Knowledge Center, where we can search an individual term and find articles related to that. I'll search Quick Connect and find the How do I change the Quick Connect ID for my Synology NAS article. Below, there's step-by-step instructions to achieve that goal.